Hi, everyone. So today we're going to talk about logic proofwriting in a two-column format. Now, before we get into this video, you do need to be familiar with the laws of inference. So if you have not seen the video on the laws of inference, please leave this video and watch that now. If you have seen it, let's get right into it. So a mathematical proof is just a convincing demonstration that some conclusion follows from a given set of circumstances called the premise. These known circumstances can come in a variety of forms. It can be given information, definitions, postulates, which are statements which are assumed to be true without proof, and then there are laws of inference and theorems, which are arguments that have already been proven. Here's an example of a proof. This is a proof by diagram. It's often referred to as the behold proof, and it works to demonstrate the Pythagorean theorem. So if you'd like to pause and examine this video and see how this justifies that the Pythagorean theorem must be true, feel free to do that. We're going to move into logic, and we're going to start with the goals of every proof that we create. There are three key characteristics. We want a proof to be clear, concise, and justified. To add to these things, for clarity, we will be using a two-column format. So for every statement, we can see the corresponding reason. We use the reasons to justify each of the statements that we make, and we want it to be concise, meaning we don't use any irrelevant information. Okay, so here's what a two-column format will look like. We have statements on the left and reasons on the right. We'll be using these laws of inference by name as our justifications throughout each proof. So let's look at one. Here's an argument, and I've been asked to verify or prove that this argument must be true. Given the premise, we want to show that the conclusion must follow. There's a few ways we can do this. One is we can use a truth table, but that can take a very long time and can be quite cumbersome. So we want to be as concise as possible and as clear as possible. So that's why we're going to use this two-column format. So we're going to make a table with statements and reasons, and every proof always starts with some piece of given information. So I'm going to start with the first premise, if P then Q. Okey-dokes. So then I'm going to use the contrapositive rule. And I'm going to take the contrapositive of line 1, which would give me this statement. That's the law of contrapositive. Then I'm going to bring in the other premise. And I'm going to notice that I can apply the chain rule to this circumstance. And it will yield this argument. Every proof kind of follows a general pattern. We're organizing in the two columns to ensure clarity. Every reason that we put in the reasons column ensures that our statements are justified. The statements which are stated in the premise, we identify as given information. And to add further clarity here, whenever I'm using a law of inference, like I'm using contrapositive, I'm referencing which line number I'm applying that law of inference to. So here I'm using the chain rule. I'm applying that to line 2 and 3 together. So I can see if I look at line 2 and 3, how the chain rule applies to give me this conclusion. Once the conclusion is reached, I've reached the conclusion of this argument, my proof is done. I've shown that this argument has to follow from the given information. Okay. There's one other format that a proof can or that the proof can be presented in. I could say, given this information, prove the following, rather than as a typical logic argument. So we'll go through one more example using that idea. So again, I'm going to create a two-column proof. And again, I will start with some piece of given information. Here, I'll start with the first premise. So there's a lot of things that we can do here. And when we meet together in class, we'll talk about strategies in proofwriting. But for now, I'm going to just show you how the proof works. So the first thing I'm going to do is I notice that, hey, there's a negation of a disjunction. So I can apply De Morgan's laws to this to make that argument a little bit simpler. As I look at my given information, I see that the second premise is that if not P, then R. And since my goal is to prove R, I probably want to show that not P is also true. But I could use the law of simplification on this line to conclude that not P must be true, because these must both be true together. Then if I pull in that second premise, I could use law of detachment to conclude R, combining lines 3 and 4. Every proof is always going to start with some piece of given information And then we're going to make a conclusion from that information and continue to make conclusions. Then we'll incorporate some more given information and make further conclusions. As you have more experience proofwriting, you'll get more of a feel for how to plan out these proofs, and that will require some practice and feedback. And that's what we'll work on in class. So I'll see you again soon. Take care.